Yeah, so hello everyone, and today we will be seeing one of the problem from Geeks for Geeks. It says and in a range. So we are given a range from L to R, uh, and we need to find the result after applying series of bitwise AND operations on every natural number between the range L to R, including both like L and R both as well. So we are provided with few examples. We have L, R, 8, 13. So we took from 8, 9, 10, 11, 12, 13, and ultimately what we got is the result as 8. Same goes with example number 2, 2 to 3. That means AND of 2 and 3, which gives us 2. So that's nice. So how can we do this? The one very clear thought is, hey, why cannot I go ahead and just take I, which can go from range L to R, like both inclusive. Yes, you can do it when L minus R is very less. The moment the distance between L and R increases significantly, the problem starts giving us few troubles. Now in this case, suppose L is at 1 and R is at 10 to the power 9, which is 1 billion. So are you going to do 1 billion operations or 1 billion ANDing? So that's not quite possible, but we can do something better. So whenever I say that whenever you have something similar to bit operations, there's a concept of bit magic. That means bits comes into some kind of order, some kind of repetition, they follow a pattern, and there must be a pattern lying here as well. That's just we wanted to decode it. Nothing fancy, nothing much. Let's decode how we are going to do this. But before that, let's see what an AND operation is. So AND operation means like you need to have a consistence 1 and 1, then only you will get 1, else every other time you will get 0. And this goes for any other bit which you have. So if it is 1 0 ending with 0 1, it will give 0 0. Now how we can say that this logic would be optimized? Yeah, there is a good question in that. Let's take example 1. There is some subtle detail which we are not going to miss anytime. Now for this example, we are having 8 to 13, right? So 8 to 13 both inclusive. I'll denote everything into binary because this would go ahead and improve much of our understanding and tracking the pattern. Once we decoded the pattern, it's good. If I don't go and code it in the binary, I can just go ahead in the decimal. But right now we are deducing the pattern. Let's see how. So this is not but just our typical 8 denoted in the 8421 pattern. So if you're wondering what 8421 pattern is, this bit is 8, 4, 2 and 1. So this is how it is. The most significant bit is 8, and that's it. So next is 9, 10, 11, 12 and 13. So let's come back to AND. What this says is consistent ones. So the moment we see this at the least significant bit, so for that I'll just say least significant bit, which is least significant on the right hand side, and most significant bit, which is most significant, which resides on the left hand side. Now you can see that the least significant bits flips every now and then. So we are sure that hey, this is not going to give us a 1. Rest, this is also not giving us 1. The only thing I can see directly is, hey, this bit is giving me 1. So the most significant bit is 1. Rest, no, this is not giving me anything for sure, and also this is not giving me for sure. So this is a very good case, and once you go ahead and test this, once you go ahead and more analyze this, you can see that least significant bit is 0th flips alternatively. There is also least significant bit of first, which flips after 2. So you see the from 0 from right, the second bit, it has 2 zeros which is consistent zeros, then we have 2 ones which is consistent ones till 2. Same goes with second position which flips after, what do you say, 3, no 4, sorry, my bad, and it follows a pattern like 8 4 2 1, 8 4 2 1. So flips at 1, then 2 is flips at 2, flips at 4, flips at 8. But guess what, if I am flipping for every, so if second position is flipping, then I am sure that first position is 0. Why it is 0? Because guess what, if 1 is not consistent, even because it is taking 2 flips, even after 2 flips it's not consistent, 0 can never be consistent. Then I am deducing this problem just into bits, like taking out the previous bit. If it is yes, then good. I can test further. Okay, I capital, this is a grammar rule which says So that is very good understanding and a good observation till now. Now what I wanted to do is, if I wanted to take the previous number, why not just take the the first number? So here what I'm saying is, take the MSB, most significant bit. There are a number of ways you can take it. Like let's say the most simplest way to take the MSB is via log 2 of a number is MSB. So if you wanted to know more about how to calculate MSB, click the video or click the link over here, which would be displayed here. It would give a much clearer understanding. But once we have an MSB, what we are going to do is check if this MSB is consistent. So now if this is consistent, if this is not, first of all say, then return 0, because if MSB itself is not consistent, how can you expect the rest of the numbers are consistent? Now, but the problem lies if it is consistent, then that's a good one. So we can take this consistency, because guess what, and requires consistency, and this is giving me consistency. It's good, it's very good. Now we can take this consistency and then check for numbers beyond MSB. So if I'm having a number like 1100, then I know that MSB is consistent. I'll take out that 1 from the start and I'll check for 100, because I know that this 1 is consistent and this will always contribute. So far so good. And the next checking would go ahead and do the same things. It check for this number is consistent or not, and if it is yes, then good. Then it'll check for this number is consistent or not, then it checks for this is consistent or not, and that so on so forth. One more thing which I didn't mention, but it's obviously clear, that any number and with, so ending with, I'm not sure ending is a verb or not, but ending with 0 is 0. This is pretty much sure, and I guess everyone knows this till now. This comes under basic electronics as well, so not a big deal. So which means like if L is 0 or R is 0, then ending would be 0, return 0. This is the basic thing. So if I'm going within the code and the logic seems concrete right now, till now, then yeah, nothing is stopping us from getting into the code. I'll get the MSB as per our logic. So there will be two MSBs, MSB of left and right, the leftmost number in the range and the rightmost number in the range. So how we are getting this MSB is log 2, log of base 2 of n. So I'm taking mat.log of L divided by mat.log of 2, yeah, and this would give me a double. That's why I'm converting it into the int, and this would give me a number. Like if MSB would be 0th, so in this case the MSB is 8, but it's giving me the position, so it would be 0, 1, 2, 3. It would give 3. I don't want that, to be frank. I just wanted to get the number, the decimal number. Since now we are clear with the logic, decimal number I can operate with that. So we'll take MSB of the right as well, same thing. The only difference is I don't want the left side, I want the right side. I have MSB left and right. Let's check if these are consistent. If MSB left is not equal to MSB right, that means it's not consistent, return 0. But if it is consistent, if it's not consistent, we return the 0. This is check marked. Now if this is consistent, we can take this, okay, then check from the number beyond MSB. I'll just copy this one, paste this over here within a comment, obviously, because it's English. Okay, we can take this one. Yeah, we can take this one, which is MSB L. Take L or right, because till this point MSBL is equal to MSB right, so you can take anything. ORing with check. How we are going to check? Check with this method itself. Check with this method. Now I wanted to not take this number but the rest of the number. How can I get the rest of the number except the MSB? Very good thing is, the only thing we want, let's suppose taking this number 1011 and I have 1000. So I don't want 1, I want rest of the numbers. Exclusively I want these numbers, so I would use the exclusive OR. So L XOR of MSB L along with R XOR of MSB L or MSB R, anything you want. Like at this moment both are same. So yeah, that's it. Let's compile it if we have any compiler errors right now. It seems none so far. Let's submit this code to check whether this logic is consistent or with, okay, cool. It is submitted with the rest of the test cases as well. I hope things were much more clear when it comes to bit magic, and this was asked in, okay, it was expecting to take login and we took the same. Cool. That was for it. I am not sure whether it's asked in companies or not. Generally companies don't ask more bits until and unless they want a low level or optimizations or something. But again, it's good to have, it's good to know. But for more such things, what companies might ask, you can click the video on your right, and I'll see you in the next one.